with VNet peering. And let me jump right into my deck here and we'll get started. Just by way of introduction, so my name is Steve Ross. I'm a cloud solution architect with Opsagility, and I've been with the company a little over a year and a half. Prior to that, I was with Microsoft for almost 7 years in various roles. So today we're going to be sort of starting our conversation with a brief discussion about Azure Virtual Networks, kind of what those are. They're sort of the core or most fundamental thing that we talk about when we mention networking in Azure. Then we'll discuss how you can connect different virtual networks. And then finally, we'll finish up with some use cases for VNet peering. So I'm going to be covering a few slides probably for about 15 or 20 minutes, and then we're going to jump right into some demos so you'll get to see peering in action. So let's jump right in with this concept of Azure Virtual Networks. So Azure Virtual Networks, as I mentioned, they are the most fundamental thing that we talk about when we mention networking in Azure. An Azure Virtual Network is an isolation boundary. It's a private network. This is going to allow me to define my own address spaces, IPv4 address spaces, and then segment up that network with as many subnets as my application requires. The virtual network is also going to allow me to control the flow of traffic between subnets as well as inbound and outbound. As I mentioned, it is an isolation boundary, so you define what traffic can come in or exit that virtual network. The virtual network is going to be comprised of front-end access, so this would be access from the internet. So if we are hosting a public website on IaaS VMs as an example, we might allow front-end access into that website. It also is comprised of back-end connectivity, which would include hybrid connectivity. So this would be scenarios where we're connecting our on-premise environment into an Azure Virtual Network so that we can sort of set up a hybrid networking or cloud connection and burst workloads into Azure. So since I mentioned that virtual networks are an isolation boundary, it stands to reason you would ask the question, how would I connect virtual networks then, since they are isolated by default? Another common question is, if I can put everything I need in a single virtual network, why would I have multiple virtual networks in the first place? And of course, I'd need to have multiple VNets in order to want to be able to connect them. Well, it's very common for most enterprise customers that have a very large organization to spin up multiple Azure subscriptions. Now, an Azure subscription is going to contain a virtual network, one or more, and a virtual network cannot span subscriptions. And so you can see in this example on the slide, I've got, let's say, an environment or an organization that has these 3 departments, the marketing, the IT, and the HR department. You can see that they each have different virtual networks and they have quite a bit of infrastructure deployed in each virtual network. But by default, again, these are isolation boundaries. And so a company like this is probably going to want to connect these virtual networks. So let's talk about some of the options for connecting virtual networks. There's really 2. Now, the first option is sort of the traditional option that we've had since the inception of Azure. And that is setting up a site-to-site virtual network between these different virtual networks. Now, this is going to work whether the virtual networks are in the same Azure region or whether or not they're in different Azure regions. And you can see here in the diagram, I've got 2 virtual networks. One is set up in East US, the other is in West US. And I've deployed virtual network gateways. And then I've connected those VNets using a site-to-site VPN connection. Now, the more current, or I should say the newer way to connect virtual networks is called virtual network peering. Now, this came on the scene last year in Ignite. So this will be around, I guess, July of 2016. And this is going to allow us to connect virtual networks as well. Now the difference is that these virtual networks must reside in the same Azure region. You can see here I've got two VNets, but they're both in the East US region, and I've set up a peering situation or connection between those two. I think it's helpful to consider the pricing of these two scenarios when we talk about connecting VNets. So first, let's talk about connecting two virtual networks via a site-to-site VPN connection. Now again, prior to about the middle of last year, this was the only way to connect virtual networks. So part of the pricing using site-to-site VPN connections to connect to virtual networks is setting up VPN gateways. And as you can see, I've got 3 of the gateway options here that are available, and they're somewhat pricey in terms of per month costs. So if we look at an example here, let's say I have 2 virtual networks in the same Azure region, and I'm connecting them via site-to-site VPN. The 1 month cost for that is going to be a little under $300 because I've deployed a VPN gateway in both of the virtual networks. Now, because they are in the same region, we're not going to be paying for bandwidth that's traversing, that connection. They're in the same region, and we only pay for bandwidth in Azure when it is egressing or leaving an Azure region. So let's look at the peering situation for pricing. So for peering, we pay 1 penny per gigabyte of inbound data transfer and the same 1 penny per gigabyte outbound. So if we look at the same sort of example where we connect 2 VNets in the same region with peering, and let's say we transmit about 500 gigabytes of data over the month, we're going to pay about $10. So you can see it's a pretty substantial difference. In fact, if I really want to kind of ramp up those numbers, I'd have to transfer over 14 terabytes of data with peering to approach that same cost for the VPN gateway connection type. It's a pretty big benefit here in terms of pricing. So VNet peering, pretty straightforward to do, and I'm going to demo it here for you shortly, but this allows us to connect those 2 VNets in the same region, and it does utilize the Azure backbone or the Azure private fiber network to connect those 2 VNets. And really, for all intents and purposes, those VNets appear as a single virtual or a single network connection, although we do still retain both VNets as separate resources that we can manage and grant access to via role-based access control. Another real big benefit of VNet peering is that the connectivity between the VNets when peering is enabled is going to experience exactly the same throughput as if I was in a single VNet. And you'll see that when I demo here. I'm going to be pinging from one server to another, and you'll see the latency is extremely low, under 1 millisecond generally. Another couple advantages here of VNet peering, as I mentioned, it's low latency, high bandwidth connectivity, but it also gives us the ability to connect a virtual network that's defined in the Resource Manager framework with a virtual network that is provisioned in the Classic or Azure Service Management framework. Now this lights up some interesting migration scenarios. So if I can set up a Resource Manager based VNet and peer that with my Classic VNet that maybe I've had deployed for some time, I can look at some interesting migration scenarios to get my workloads migrated into the Resource Manager framework, which is the strategic direction, obviously, for Microsoft Azure these days. Couple of caveats, always good to consider the caveats of a solution. First off, VNet peering is between 2 virtual networks. There's no derived or implied transitive relationship. You can see in the diagram here that I've got virtual network A peered with virtual network B. I also have virtual network C peered with virtual network B. But it's important to understand that in this scenario, there's no implied connectivity between A and C. Also, when you're going to peer virtual networks, it's important to know that those address spaces that are defined cannot overlap. You can definitely peer virtual networks that are in different subscriptions. However, both of those subscriptions need to be linked to the same Azure Active Directory tenant. And that's really what I'll demo for you here in just a few minutes. I've got two subscriptions linked to the same tenant, and I'll be setting up a peering relationship between them. Also, definitely note that inter VNet traffic, when you're setting up peering, so traffic between peered VNets, there is no encryption that happens on that traffic. And that's quite different from what we used to do in the past with a SitetoSite VPN. Of course, a SitetoSite VPN, by default, the traffic is encrypted. Also note, when you peer virtual networks together, that you're going to have to supply some way to resolve names. Within a virtual network in Azure, we can use what's called Azure provided DNS, and it resolves names within that VNet. But if we want to resolve names outside the VNet, we'll need to use our own DNS capabilities. And there are also some limitations, both default and maximum per subscription, for the amount of peering relationships you can set up, and you can see the bullet there. Well, that's just a bit of information about peering. Let's get into some of the use cases for peering. So first off, when we build our deployments in Azure, especially as an enterprise, many times again, we will be using multiple subscriptions. Now, this is because large enterprise organizations, sometimes they run into the limitations in a subscription. But more commonly, they want to break out their costs. They want to kind of break out the costs by department. And you can see here in the example, I've got a marketing, an IT, and an HR department, each with their own subscription. Now, the thing I want you to look at and notice in the diagram here is that each of these subscriptions has a virtual network, and in each virtual network, there is quite a bit of infrastructure that is really duplicated. Like you can notice, for example, that I've got domain controllers that are in both of my, or excuse me, all three of these virtual networks. Notice that I also have firewalls in all three, and also have a monitoring server in all three. And so that's a bit overkill, really. But if you think about it, if these VNets are not connected, I might have to do that. So let's look at what peering allows me to do. You see, if I peer those virtual networks together, and in this case, it's like a hub and spoke where marketing's peered with IT and HR is peered with IT. Now I can leverage the infrastructure that's deployed into the IT virtual network, and I really can get rid of a lot of extraneous or duplicated infrastructure in marketing and HR. Well, obviously, this is a much less complex deployment. Less complex means easier to troubleshoot, but it's also quite a bit less cost. All of those IaaS servers that I don't need anymore, well, that's just a tremendous cost savings to me. And also, again, I'm not using gateways to connect these virtual networks, and so again, another price savings there. Here's another scenario that is useful when we talk about peering. This is called service chaining. Now, in this case, what we're doing is we have set up a peering relationship between marketing and IT and HR and IT, and we are using what are called user-defined routes. And this allows us to define the routing characteristics of the traffic between these VNets. And in this case, I've set up user-defined routing to forward as to the next hop, the firewall that's defined in the IT virtual network. So I've got a single firewall, or maybe a pair of firewalls I've defined in the IT virtual network, and it's being shared by the other virtual networks. And again, this is thanks to peering. This is what enables peering, or enables that service chaining, and also user-defined routing. Now, another scenario that is quite useful is what is called gateway transit. In this case, you see I have an IT subscription and an HR subscription, both with their own VNets. But notice that there's a gateway, a virtual network gateway that is defined, and that's defined between the IT virtual network here and an on-premise environment here. Well, in the past, I would have to set up the same thing here from HR. I'd have to set up another gateway to connect into that on-premise environment. But now, thanks to peering, I can do what is called gateway transit, where the IT virtual network is allowing other peered VNets to use its gateway to get to on-prem. And the reverse is also true. Traffic from on-prem will be able to get to all of the peered virtual networks. Let's take a look at a couple of demos here just to show you peering in action. And I first wanted to introduce you to my demo environment. You know, sometimes when demos happen, it's kind of hard to kind of track what's going on because you're not aware of what is deployed in that environment. So let's start with what's going on in this environment. First off, I have an information services subscription. It is a separate subscription, and it has a virtual network with the 10.1.0.0/16 address space. Got a couple of VMs deployed there, a management VM and a Linux VM, and I do also have a gateway, a VPN gateway deployed there. Now I also have an environmental department subscription with its own virtual network. 10.0.0.0/16 is the address space there. And the environmental department in my demo has a web application that's deployed in that virtual network. And there's also a Linux server that's deployed there. Now I also have an on-premise environment in my demo here. This on-premise environment has a gateway set up, and it also has a Linux server, and you can see the address space 192.168.0.0/16. Now I've set up already before this demo, I've set up a site-to-site VPN connection between the information services virtual network and the on-prem network. So those two are already connected. Okay. So what we're going to do in the course of our demo is first I'm going to set up peering. So I'll just walk through the configuration of peering with you, and we're going to definitely enable not just sort of vanilla peering, but we will also enable gateway transit for the IS virtual network and using of remote gateways in the environmental department VNet. And we're also going to demo connectivity once this peering is set up. You'll see that I'll be logged into the management VM in the IT or IS virtual network. That's right here. Now from this management VM, I'm going to connect using a name, the name intranet, with my browser, and I'm going to connect to this website hosted in the environmental department. Now I'll resolve this name for you so you'll see it's a private address, and clearly this connectivity would not work unless peering was working. So that's going to be our first way to demonstrate that peering is working. And then the last demo is I'm just going to do a few pings. So I'll ping, first off I'll be logged into this Linux server here in the IT department. I'll ping the Linux server in the environmental department first, and that's going to show you the very low latency of this connection. And then I'll also ping the Linux server in the on-premise environment. And you'll see that latency is quite a bit higher because it's a traditional site-to-site connection. And the last thing I'll do is I'll SSH into the Linux server here in the environmental department, and I'll ping this Linux server on premise, and that's going to demonstrate the VNet gateway transit that is enabled. Okay, so let's jump right into the environment. So I've logged into the management server, as I mentioned. That's the only server with a public IP address in my environment. And right away you can see that I've got two subscriptions that are defined, the environmental department and the information services department. So let's set up peering between these. What I'm going to do is go to the list of virtual networks, and you'll see that there are two VNets. And if you look all the way over to the right, you'll see that the subscription that they're in does show that there are VNets in different subscriptions. So setting up peering is super easy. I'm going to start in the environment VNet. I'm just going to click on that virtual network. And here in the menu options of the VNet, I'll click on peerings right here. So I'll click on add. So we're going to first give it a name, and I like to be a little descriptive here. So environmental subscription or VNet 2 IS. This is going to be a resource manager VNet. Now I want to choose the subscription I'm going to be connecting to. So I'll choose the information services subscription, and I'll choose the virtual network in that subscription I want to connect to or peer with. And that's called IT VNet. So I'll select that. Now the last thing that I want to set up or select here in this list is I want to select use remote gateways. That's because if you remember from my diagram, let's see if I can bring that back up. The only gateway that exists is in that IT environment. So I want to use a remote gateway from this virtual network here. So use remote gateway is turned on. Now let me briefly describe what these other options are. First off, allow virtual network access. This simply means that once the peering is set up, we're allowing traffic to traverse that peering relationship. I'm not sure why you would set this to disabled, but you could. That would basically disable the traffic from traversing that peering relationship. Now you can also set up to allow forwarded traffic. What that means is that this virtual network is, or the peering relationship, will allow this virtual network to receive traffic that originates from another network not peered with it. So we're not going to select that today. And then allow gateway transit. This is what we would select if we had a gateway in this virtual network that we wanted to share with peered VNets. Okay, so everything is set here for this peering. Let's click on OK. The peering usually takes about 20 seconds or less to get set up. You can always check here to view our notifications, and here we go. We see that it is now set up. And if I kind of refresh this by clicking on DNS servers and then back on peerings, you'll see that the connection is set up, but it is set up really on one side. Peering has to be configured on both sides of the connection. So it has a status of initiated right now. So let's set up the IT side now. So we'll click on that virtual network. And again, click on peerings. We'll click add. Okay, this time we're selecting the environmental department subscription and the virtual network defined there. And the option we're going to select here is to allow gateway transit. Again, because we want to share that gateway that's defined in the IT VNet. So we'll check that box and then click OK. That peering only takes a couple seconds to set up. Pretty easy, as you've seen. And let's just refresh that view. Okay, so we can see that it is connected, and I'm sure that the other side of the connection also shows connected. Let's just validate. Yep. Okay, so we see that we have that peering situation or configuration set up, and it is connected. So let's give it a test. So again, the first or the second thing I'm going to do, since I've now set up peering, is I'm going to connect from management server where I'm RDP connected into it. I'm going to set up my browser and connect to intranet, which is going to hit a load balancer for this web application defined in the environmental department. So got my browser already open because I'm looking at the Azure portal. Let's just open another tab. And first off, let me resolve this intranet name, just so you can see that that is a private address. Okay. Not going to be able to ping it just because we can't ping the load balancer there, but that's fine. Okay, so let's minimize that. And here in our new tab, we'll go ahead and connect to intranet. And sure enough, here is our sample web application. You can see that it's running on web VM1. If we refresh this a couple of times, you'll probably see that this changes to 2 occasionally, except when you're doing a demo. But there it is. There's 2. Okay, so we see we're connecting just fine across that peering relationship to the load balancer, again, using a private connection. All right, so let's do just a couple more demos to show you a bit more about peering. So I'm going to SSH into the IT Linux VM here. Again, that is the one that's defined right here in the Information Services VNet. So we'll just double click on that. Okay, and you can see I am connecting to a private address and I've logged on successfully. So what we want to do now is ping a couple of things. Again, we're going to ping from this server first to the environmental department Linux just to show that that connection's working and to show the very low latency across this peering connection. Then we'll ping the Linux server on-prem and look at that latency. So I happen to know the IP address for the environmental Linux server is 10.0.0.6. Okay, I'll just let this go a couple of pings and stop that. Now I want you to notice the extremely low latency here. We're doing under 1 millisecond of latency from the IS virtual network to a virtual machine in the environmental VNet. And again, that low latency is because the peering is using the Azure backbone. So very, very fast and low latency connectivity. Now let's ping the on-prem Linux server. I believe that's the address. Yes, it is. Okay, now notice that we do have connectivity, so that's great, but do notice that it is quite a bit higher in terms of the latency. And again, a site-to-site VPN connection, that's just a characteristic of it. The latency is going to be higher. It's not traversing the Azure backbone per se. All right, so I wanted to do one more quick demo with you. And what I'm going to do now is SSH into the environmental Linux server. Okay, and you can see its address right here, a private address. And what I'm going to do now is ping that on-premise Linux server just to show that, in fact, we are sharing this gateway with peered VNets. Because clearly, if I can ping this server, it's going to have to be traversing this peering relationship and this gateway connection. So let's try this. Okay, so we see we are getting replies, and we see the latency is about what we would expect, given that it's a site-to-site VPN connection. The real key thing here is that we're traversing that peering relationship as well as using the shared gateway. So those are the demos that I have for you today to kind of illustrate peering. And now just have a couple of quick takeaways, and then I want to make sure that you have a chance to ask any questions that you have. So by way of summary and takeaways, I think peering, one of the great things about it is just the ability to reduce cost and complexity. You remember seeing what I showed a bit earlier when we're peering between VNets, we can really share a lot of the infrastructure and reduce complexity and cost. You saw that it's super easy to set up, and it also leverages the Azure backbone, so the connection is very fast. Really, the only thing that is limiting the bandwidth is what is defined for the virtual machine series and size that you're using, because there are bandwidth caps per VM series and size, but it's not the peering relationship that's limiting that. Also, you saw there's no gateways that are required, and the connectivity appears like a single network. So very, very useful capability. So at this point, I want to encourage you to ask any questions that you may have. So there is a chat window that you can type in your questions, and I want to make sure that you get those answered. So feel free to chat away there and ask a question. I'm also going to, in the chat window, I'm going to put in my email address. That should go out to the entire audience. And I'm giving you that because I want to make sure you have an opportunity. If maybe you forget to ask, you don't think of the question until after the webinar is over, feel free to email me, and I'm happy to respond to any questions via email as well. So any questions at all?
Steve, I do see one from Kumar. It says, how is the cost distributed between subscriptions for shared components?
Good question. So it just really depends on where the components are created. So when an organization has multiple subscriptions, let's say one per department, the infrastructure that's deployed in, let's say, the HR subscription, that's going to count against a quota perhaps that's set for the HR department. So when the peering is set up, generally speaking, that cost the IT or IS department, kind of eats that cost. Hope that answers your question.
Yeah, we have a few more questions rolling in now. Juan is asking for you to elaborate on the IP address space restrictions of the separate VNets.
Sure. So if I'm going to peer two different VNets together, I cannot use overlapping address space. So what that means is I just have to make sure that the address space is defined in those virtual networks does not overlap in any way. It's pretty much as simple as that. Great question.
Okay, next, David has a question. Would ExpressRoute be used in any way?
Potentially. So it is common that ExpressRoute would be set up, but remember, ExpressRoute is a hybrid connectivity capability. So if I am a large organization, almost certainly I will eventually be using ExpressRoute, and that's going to allow the connection between my on-premise environment to my my virtual networks deployed in Azure. Now the difference is that whenever I'm deploying ExpressRoute, if I want to link my virtual networks to the ExpressRoute circuit, then I will have to deploy a gateway in the virtual network to allow that linking to take place. Yeah, so definitely you can use ExpressRoute in conjunction with peering, but yeah, that's kind of the scenario there. Good question.
Okay, we have a couple more right now. Soma asks, how do we access resources from C to resources A, as we will not be able to do the peering between VNet C and Net A?
Good question. So you actually could do that. I mean, you could peer between C and A if they're in the same region, Azure region. But if you do not do that, the only scenario really that would be available is to use gateways along with BGP to allow routing, between virtual networks connected in kind of a tiered way with gateways like that. So I'd say either peer CNA or use gateways with BGP.
Okay, and our final question. Oh, nope, got one more. Raghava asks, is it a shared backbone, unencrypted for all customers?
Right. So remember that we're talking about one customer that has multiple virtual networks, and when you connect those via peering, the connectivity is not encrypted, but it is connectivity that, number one, is for a single customer, and it is traversing the Azure backbone, which is a private network. So yeah, it's private, but it is not encrypted.
Okay, we have a few more that are coming in now. Fadil asks if the deck will be sent to the attendees. I can answer this one. We actually will not be posting this deck to the attendees, but this video will be available on our YouTube channel, so you can go back and review it at your leisure. The next question, another follow-up from Soma: is it possible to show how it can be configured? And I'm assuming this goes back to the original question of access resources from C to resources A.
Yeah, well, I don't have another VNet configured that I can show you right now, unfortunately, but it would just be setting up a peering relationship between C and A. So you saw how I did that. It's pretty straightforward. But yeah, I don't have the ability to show the configuration of it, unfortunately.
Okay, and one last question. Which peering is suites for small scale applications?
Not sure I understand that question, but yeah, I mean, I think peering is a great scenario for connecting VNets in the same region, regardless of the size of your company. Now, however, generally speaking, smaller organizations will many times deploy a single virtual network within their single subscription. And in that case, there's no need to connect virtual networks. But if you're a small company and you for some reason require more than one virtual network and they're in the same region, then peering is a great answer. I would always use peering instead of site-to-site VPN connections, as long as I don't have to have the traffic be encrypted, and as long as the VNets are in the same region.
Okay, next question. How is the IPv6 address allocation supported? In the Azure documentation, it says it's supported. Is it only on PS?
Yeah, in my understanding, and I will definitely concede to possibly being wrong here. I'm wrong often, seems like, but yeah, my understanding is IPv6 traffic is supported between virtual machines, but when you're configuring a virtual network, the only option is to use IPv4. That is my understanding today, but if I'm wrong, please feel free to post a link in the chat window there to documentation, and I'll also research that. But yeah, my understanding is it's just IPv4 when you're talking about configuring the VNet today.
And the last question, it looks like, from Bobby: can tags transcend subscriptions for billing purposes?
Good question. And I wonder if this is the Bobby Appel that just passed his 70-534. If so, congrats again, Bobby.
Indeed it is.
Welcome. Yeah, welcome to the call, Bobby. Yeah, so no, tags are bound to the subscription. So when I define a tag, a resource manager tag, it exists in the subscription. It does not exist outside of it. And so the benefit when I have a large organization, and let's say I'm using an enterprise agreement to license Azure, I can use things like the enterprise agreement, Azure portal, to help me track costs across departments. But no, unfortunately, tags do not. They don't traverse subscription boundaries, unfortunately. Good question.
Okay, next question. How many subnets can create under one VNet?
That's a good question. Let's look at that together. I don't have the answer, but one thing that I'll recommend that you do is get used to typing this search string here, Azure Service Limits. Just type that in your favorite browser. Probably the first link is going to be the Azure Subscription and Service Limits. Hope you guys can still see my screen, by the way. I'm just showing you this, but when I'm in the Azure Subscription and Service Limits section here, I can go down to the topic I'm interested in. This is networking here. And then I usually just do a find on the page, and you're asking about subnets. And there we go, subnets per virtual network. 1,000. Now that's the default limit. In Azure, there are default limits. These are the limits you run into first. And then there are maximum limits. These are limits that cannot be increased. So it sounds like if you need more than 1,000, you can contact support, but I don't see in the documentation the absolute maximum, but hopefully that answers your question.
Okay, that was the last question. Open it up for one more opportunity to see if anybody else has anything else they'd like to ask Steve while we're online here. Okay, one has a follow-up question. Does Resource Manager lift the need of having multiple subscriptions for the purpose of tracking cost within a single enterprise?
Good question, Juan. I would say no. I mean, Resource Manager brings different ways to track costs like tags and resource group membership, and that all does bubble up to the bill. However, larger organizations still commonly are going to deploy one or more subscription per department. And that's just because it supplies them with a great sort of administration boundary as well as a billing boundary. It just makes it a little bit easier to track costs for a larger organization. Sometimes tags and resource groups can be challenging when you're talking about tracking costs at scale. So I would say Resource Manager helps, but it does not really eliminate the need or desire to implement more than one subscription for large orgs. Good question, Juan.
Okay, a couple more looks like. Ragava has asked a follow-up question. Can you please elaborate with a use case about the forwarded traffic under option under configuration?
That's a great question. And I don't know that I can, to be completely frank and honest with you. It's a scenario I've never set up or used in a lab environment, so I don't think I can elaborate on it. I can just tell you that the purpose of it is to allow, so if I check that box within a VNet when I'm setting up a peering relationship, the purpose of it is to allow traffic to traverse that peering relationship into that VNet that did not originate from a peered network. That is the sort of the textbook definition, but I cannot really elaborate beyond that. I'm sorry. It's a great question, though. Okay,
there was one more. I was trying to rearrange my pane here, and it closed off on me, so I apologize.
Yeah, I see the question.
Okay,
so
cool.
Question is, can one VNet be peered with multiple VNets? So the answer is yes. I mean, I can definitely peer. In fact, I showed you a diagram where I have like multiple departments that are peering with the IT department. And so in that case, I've got one VNet, the IT department VNet, that is accepting peering relationships from multiple other virtual networks. So in that case, it's kind of a one-to-many. But yes, the answer is yes to your question, Soma.
And Steve, I don't know if there was a follow-up after that as well.
I don't see another question yet. Yeah. Got a few more minutes though before the top of the hour, so feel free to ask another question if you have one. And so far, Rakawa gets the prize for stumping the instructor here. I did not have an answer to his question, but yeah. Any others? Well, if not, let me just say before I turn it back over to Jay how much of a pleasure it was to spend the afternoon here with you. I hope this training was helpful. And I definitely hope you'll check out the video once it's posted on YouTube. And yeah, thanks so much for your time and for attending today.
Yeah, I just wanted to follow up and just say I know that at least one person had reported into support that they weren't able to access the webinar. And again, as Steve said, this video will be posted to our YouTube channel shortly, so you'll be able to review it there. Again, for those that did not see Steve's email address for other questions, you can email him at steve@opsagility.com.
I do see one more here from Sema. How about assigning network security groups? So can we add new network security groups for VNet? Absolutely, yeah. You can definitely still leverage network security groups. Those always, as you know, can be assigned to a subnet or to a network interface card on a VM. And in fact, I can do both, right? So I can get very granular with the application of those network security groups. So absolutely, I can still use network security groups just as though peering didn't exist. It's still going to control the flow of traffic inbound and outbound based on where I assign it. Good question, Sema. And will that get applied to both the VNets? It only applies to the scope where you apply that network security group, right? So if I have two VNets and I've peered them, I can't link the network security group to the peering, if you will. I can link it to a subnet within a VNet or to a NIC on a VM. And so it's going to apply to the scope that it's applied to for inbound and outbound traffic based on the rules I set. Does that make sense, Soma? Great. Another question, if you take advantage of a virtual firewall appliance to control traffic in and out of Azure, can this device traverse traffic to another peered network? So I think I understand your question, Mike. Correct me if I get it wrong, but you can definitely set up a firewall or a pair of firewalls in one virtual network, and then you can use those firewalls in conjunction with user-defined routes. You can use those firewalls to control the flow of traffic alongside of peering or in a peering scenario. So I showed a diagram earlier. In fact, let me get back to it real quick. We still have a couple minutes here. Here it is. So you see in this example, service chaining. So here in the IT department, the firewall is deployed and the other peered VNets are using it. So you're asking, so the firewalls need to be in a different VNet? No, they just need to be in a different subnet. Generally speaking, the subnet, or the virtual network appliance, I say generally, really always, a virtual network appliance in Azure needs to be in its own subnet within a virtual network, but not in a different VNet. Hopefully that diagram helps, Mike. Some asks, how about peering between two different subscriptions which are in different regions? Yeah, unfortunately, you can't use peering between VNets in different regions. And so, really the subscriptions, though, are not defined in a region, honestly. A subscription kind of traverses regions. But when you create the first resource in the subscription, that's going to be defined in a region. And so I would say it still applies that you can define virtual networks in different subscriptions, and as long as they're in the same region, you can peer them. If they're in different regions, you've got to use site to site. That's the only answer, unfortunately, Soma. I have heard, don't quote me on this, but I've heard that it is on the roadmap eventually to enable peering for VNets between different regions, but I have no information on whether or not that rumor is accurate and what the timing on that will be. But for now, I have to be in the same region.
Steve, just a couple other questions regarding the video for YouTube. If the users or students here want to go and see the video, it should be available probably within the next 24 to 48 hours. And if you just go to YouTube and type in search for Opsagility, you'll be able to see all the videos that we have listed there.
Probably have time for one more question if anybody has a burning question they've been wanting to type in. Okay, if not, again, many thanks for attending today. It's been my pleasure. I hope it was helpful, and I'm going to turn it back over to Jay.
Yeah, again, guys, just thanks for everybody. Thanks for the participation. Lots of great questions for us today. And again, look forward to seeing you guys soon, and check out our YouTube videos. Thanks again.